Again, this is Wi-Fi Tech Lab channel. We're still on the same topic of dynamic routing protocol. Today we will be focusing on this OSPF lab. If you take a look closer to the application that we're using today, we're using a web-based application which we're actually utilizing EVE-NG. If you remember, we've been using the Cisco Packet Tracer all along, but in this time, if you're willing to also use this kind of application, you can just go to EVE-NG website, and then you'll be able to go to downloads. Under downloads, you will have to navigate to this option where you can actually download the ISO file. Of course, you will need a VMware player in order for you to be able to use the ISO file, and then you can also check these required installation application, also Wireshark, Ultra VNC, Party, and furthermore. Okay, so now let's go back to the topology. Okay, from the left hand side we have an in-host device. This is just a single PC. This is just a computer running Windows. I will show you exactly what operating system we're currently using at the moment. And then we have these two routers. They are directly connected, and then we have the dead router, which is actually directly connected to the WAN. Okay, it connected to the internet. As you can see, we are using this kind of a cloud icon so that you will be able to see that this is our internet. Our internet is actually nested to, so basically with this application uses my resources of the computer that I'm currently running. Okay, so basically my storage, my CPU, and also my network configuration or the network interface card, because I've breached this, so we are using that internet. In that case, we will be able to actually use this application here. I mean this operating system which is running on that PC. This is Windows 7. Okay, this is Windows 7. So as you can see on the network interface card, if I type in ncpa.cpl and then press enter, this takes me to the network interface adapter settings, where I will actually come in here to properties, navigate to IPv4 settings, and then I've chose to use a static IP because I'm not going to configure any dynamic host configuration protocol in there. So I'm just going to use this static IP to actually try to connect this Windows 7 to that interface, which will act as a default gateway of this Windows 7. Okay, so currently we are using that network ID, which is 192.168.10.0. In this case, the usable IP address of this is actually .2. So this is the first usable IP address that we're going to be using on that network ID. Okay, and this is our subnet mask, which is 255.255.255.255, and of course this is our default gateway, which is 192.168.10.1. On our DNS server, we actually used 8.8.8.8 because this is actually the Google DNS that we'll be using, so that our PC will be able to break out to the internet. And then we have this alternative DNS. You can always, if you want, you can use the alternative DNS as the Cloudflare. You can use it as the default gateway even, but in this case I just use it as a Cloudflare. Okay, so now what we are willing to do, we're willing to do the configurations on these routers. Okay, we're willing to do the configurations on these routers so that we will be able to see the OSPF actually being utilized on this topology. And then we're willing to see this PC to be able to use the OSPF as the dynamic routing protocol to access the internet. Alright, let's start by showing the configuration that we have on each router, and also the IP address that we have actually assigned to these interfaces per router in the network topology. Okay, so let's start by the router on the left hand side. Obviously, if you want to access the router, obviously you will use a console cable and you can use PuTTY on your laptop or on your desktop to access that router interface. Okay, now let's click on that PuTTY and wait for it. Okay, and then our router will just take us in here where we actually have to type in the command enable. Once we type in the command enable, we can navigate to global config mode if you want to do some configuration. But however, if you want to show some run, if you want to see some configuration data existing on that particular router or that particular switch, you can always just run the command show run configuration on that privilege mode. Okay, now let's just go to the global config mode. Okay, we are willing to go to the global config mode. So I will type the command config terminal, and then I want to actually show the IP addresses that are assigned on each interface on that router specifically. How am I going to do that? There is a special command that we use, which is say do show IP interface brief. Remember, I'm just using all this in short. However, you can always type all of these words in full. So you can just type in the command do show IP interface as full and then brief as full. You will get the same results. Also, what we're looking at now on this table, we're actually looking at the interfaces that we have on that routers, and then we can also see the IP addresses that are assigned on those interfaces. Okay, so we can also see the status of those interfaces, if they are down or they are administratively down or they are just up. So what you see now, the protocol and the status is showing up. So this interface is actually ready to communicate or to let the packet pass through. So let's do this now. We are willing to check two interfaces on this router. Let's focus on that. So let's start by the gigabit Ethernet 0/2 on the left hand side of the router. In this case, I will just come in here and check the IP address that we have configured on that interface. If you pay attention, you will find that we have 192.168.10.1. Okay, this is the IP address that we have assigned on this interface. And then on our right hand side interface, we can see that we have gigabit 0/0. This is the gigabit 0/0. This is the IP address that we currently assigned on that interface on that router. And then we have also the visual or the logical interface, which is a loopback interface. This interface is always ready to be up. You just need to type the command loopback and specify the number of that loopback interface, and then automatically it's going to come up. There is no need to type in some command no shutdown, so it's just going to come up automatically. And then we have used this IP address. As a result, that we're willing to use the OSPF. Remember, on an OSPF, this is very important. So if you running an OSPF instance, you need to specify the area ID, and then you also have to specify the router ID. Okay, so on the router ID, you must make sure that you actually configure the router ID, because if you don't configure the router ID on an OSPF, the OSPF will use the highest IP address that are assigned on those directly connected interface on that router that's running OSPF. Okay, so the reason why we have chose to use this loopback 0 as our highest IP address compared to any other IP addresses that we have on the router, on this router. As you can see, the gigabit 0/2, it's actually using 192.168.10.1, which is actually less than this IP address. Okay, so this is the highest IP address that we have on this router. Just in case if somehow we don't configure the router ID, the OSPF will use this interface. Okay, it won't take in the IP address of any other interfaces, because if the OSPF takes this IP address, and then this IP address won't have an IP address to use to communicate to that router over there. Even if there is a dynamic routing protocol, it won't form the adjacency with that router, because now the OSPF have utilized that IP address to that router ID. I hope that makes sense. Now let's actually check what is the subnet mask that we are using on each of these interfaces. Okay, let's start by checking the sub interface. Let's start by checking the subnet mask of this interface, which is gigabit 0/2. We need to type in the command do show interface, and then we need to specify that interface that we want to see some further details. In this case, we're starting by this one over here, which is 0/2. So as you can see, this gave me the whole detail of that interface. Okay, if the interface is up, what is the MAC address running in there, what is the IP address assigned in there, all of those. Okay, so the first thing that we are willing to check in here, we want to check if the interface is up. We already saw that. And then we are willing to see also that this is the description link that tells me that this interface is actually facing towards which direction. In this case, I have specified that this is just the link toward the local area network. Okay, this is my description that I've configured on that interface. And then we have this IP address which we are using. This tells me that this is the IP address that we are using on that interface, and this is the subnet mask that is used on that interface, which is class C IP address. As you can see, this is /24, and it only allows 254 usable IP addresses. Now let's check. This is the MTU. This is the default MTU size. So let's go back to another interface. Okay, let me do this. This actually take longer. Let me just wait for it. But we are willing to check another interface, which is gigabit 0. Here we go. We are willing to check the interface. Do show interface. Let me just write this in full. Do show interface gigabit 0/0. In this case, I'll be able to see the interface on the right hand side when we're looking at this router on the left hand side. This is the first router that we're dealing with. So on the right hand side interface, we can see that we have actually the interface that is up. This is the protocol that is up. And then we have this description that we have configured on that interface, where we actually said this is the link that is forwarding the traffic to R2. This is our R2, this is our R1, this is our R3. And then we have specified that this is actually the network that we'll be using. This is the IP address that we'll be using, and this is the subnet mask that we'll be using. /30 symbol means that the subnet mask that we are using is actually 255.255.255.252 on the 4th octet. Okay, so we're using 252, which means also this interface is using the default MTU size. Okay, what we wanted to see which network ID this IP address belongs to. This is the network ID. We wanted to confirm that, and then we now know that the subnet mask that is used actually is this one. Let me just write it down. It's 255.255.255.252. Okay, I'm just gonna write it down and save it. So this is the subnet mask that goes with that /30. I'm just gonna duplicate it so that we will be able to use it somewhere else. Let me select it again. I'm trying to duplicate this. Let's see if we can move it. Yes, of course we can move it. So I hope this makes sense. Yeah, let me just try to enlarge this. Okay, so what do we have now? We have that subnet mask that we'll be using between these two directly connected interface. Remember, the administrative distance between the directed or directly connected interfaces, it's just 0. Okay, so on an OSPF the administrative distance is 110. So let's just do this now. Let's move into the loopback interface. Just gonna do this. Let's go to the loopback interface. So do show interface LO0 loopback 0. Okay, so we still getting the same result as the result that we got earlier on. This is actually the IP address that we have used, and then we have decided to borrow some bits. So we have that 30, because this is actually the IP address that belongs to class C by origin, but then we have chose to actually utilize some bits to make it actually belongs to 255.255.255.252 subnet mask. Okay, so let's see now. Let's move to this router over here. I'm just gonna try to connect to this router using PuTTY. Okay, here we are. I need to enable and navigate to the global config mode. Once I'm here, remember we are trying to actually check all of those details that we've been checking on the first router. All I have to do now, I have to actually run the command to show IP interface brief. Let me write this one in full this time around. I'm trying to show the details of those directly connected interface on that router, which is router 2. If I look on my left hand side, this is the interface that I'm focusing on right now. We actually have this gigabit Ethernet 0/1, and on that interface we actually assign this particular IP address, which is 40.40.40.2, and the interface is actually up and the protocol is up. Okay, what do we want to know? Also, we want to see this interface on the right hand side of this router, which is gigabit Ethernet 0/0, and the IP address that is assigned on that interface is actually 20.20.20.20.1. If you pay attention, these are the network IDs that we're using between these links. So the network ID that we're using in here is 20.20.20.0, and the network ID that we're using between R1 and R2 is 40.40.40.0. So the first usable IP address of this network ID is actually 40.40.40.1, which is assigned on gigabit 0/0, and the last usable IP address of this network ID is actually 40.40.40.2, because /30 only allow 2 usable IP address. So you're gonna use /30 only if you want to utilize only 2 usable IP addresses, the other 2 IP address, they are utilized by the network ID and the broadcasting IP. Okay, so let's come to this interface over here, which is utilizing 20.20.20.1 IP address. Okay, and now let's check the loopback interface. If we run the IP address if we run the command do show interface loopback 0, we will be able to see that this also use this /30, and this is the IP address that we have assigned to this loopback interface. Just in case, remember, the whole purpose of this is that if we forget to configure the router ID, and then the the OSPF will actually look for the highest IP, and then this is the IP that it will find, and then it can take this IP. Okay, this is usually used to check or to troubleshoot, or if you want to check if the packet can be routed towards these loopback interfaces, if we don't want to set up some sort of the local area network just like we did in here. Okay, we can always use the loopback interfaces to just test. Okay, now let's let's just come in here. Okay, I'm just gonna come into this router over here and then try to do the same thing. All right, let me try to do the same thing. All I have to do now, I have to enable the router by typing the command enable, and then I will type in the command config terminal. From running the command config terminal, all I have to do now, I have to actually check all of those interfaces again to find out if they have the corresponding IP addresses as what we are expecting them to have on this network ID, which is 20.20.20.0. so we're expecting this to have 20.20.20.2 on gigabit Ethernet 0/1. Let's run the command do show IP interface brief. Remember, I'm running this command as do so that I will be able, I can only run this command on a global config mode, but if I was on a privilege mode, I will be able to just type in the command show IP interface brief. Okay, yeah, so let's just check gigabit 0/1 and find out if it's using .2. As we can see, it's using .2, and then let's check the loopback interface. It's using .181. Okay, and then on this interface we currently have nothing, gigabit 0/0. Okay, so let's try to explain this. Suppose this is the internet service provider. On an ISP side, the ISP can actually decide if they want to give you a link that have a dynamic, which also assign the IP address on the other interface, or you can either get the static IP. Okay, so in this case we will try to get the dynamic IP address on that interface. Okay, so how do we do that now? We have to select the interface that we want to configure. In this case it's gigabit 0/0, and then all we have to type is we have to type the command no shuts down. This interface is now currently up. Okay, now all we have to do after that, we know that the interface is actually up. As you can see in here, the interface is up, it's just that it doesn't have any IP address. Alright, so all I have to do now, I have to assign the IP address by typing the command IP add DHCP. This is going to allow the interface to obtain the IP address from the DHCP server on the other side. Okay, so as you can see now, we have that interface being assigned with the corresponding IP address of that network ID that we are using. As you can see, this is the application that I'm using, which is EVNG, and then it is actually running on 192.168.1.0 network, and this is one of the usable IP address on that network range of class C IP address. So the IP address that we got on this interface, it's also part of the IP addresses on this network ID where my web application is running, which is that EVNG. Okay, so now, which means from this router I should be able to ping that 150. Okay, so let's see if we can ping that. Do ping 192.168.101.150. Okay, for now, as you can see, we have been able to ping. For now, we're dropping one packet, but if I run another one, we will get 100% packet sent and 100% received. Okay, I can be able to ping now to that IP address from that router. Okay, let's see if we can be able to ping to the internet also. Ping 8.8.8.8. Okay, let's run this with high privilege. Do ping. As you can see, I can be able to ping to the internet from that router. Okay, so this router have the internet. I can also try to ping the Facebook facebook.com. Let's run that command again. Do ping facebook.com. As you can see, we're getting successful rate of the packet sent and packet received. Okay, and this is the IP address. Okay, now let's try to ping another website, maybe twitter.com. As you can see, I can be able to ping that twitter.com from that router. But does that simply mean that that PC can be able to ping? Nope, it won't be able to ping. Why? Because there is no route from that PC towards that destination. All of these routers, they are not aware, or on their routing table, they have no entry that leads the packet to that towards that direction, to the internet. Let's run a continuous ping, or maybe let's try by pinging the closest IP or the closest hop. The next hop or the first hop of this local area network is that router, which is router 2 on gigabit 0/1. Let's ping 40.40.40.2. As you can see, you will find that it will say timeout. Okay, so it doesn't know how to get there. Let's drop that configuration. Now let's actually try to ping to 20.20 20.20.1. Actually, we can't be able to ping that also. All right, what about 40.40.40.1? As you can see, let's see if we run the command ping 40.40.40.1. So we can be able to ping from that router from this PC to that router. Okay, because it is directly connected. All right, but as soon as we try to ping towards the other router, we cannot be able to ping. All right, so what do we do now? That's where we actually need the dynamic routing protocol. Okay, we actually need the dynamic routing protocol. Not only just the dynamic routing protocol, we also gonna talk about something else today, which is called network address translation. Okay, but before we go to the network address translation, which we're gonna be utilizing on this router over here, let's go back to the dynamic routing protocol that we're willing to use. Let's start by the OSPF, because we're gonna be focusing on an OSPF here. Let's run the OSPF instance. And then this time around, I'm not gonna show the normal way of actually advertising the network to the OSPF instance. We're gonna use another way so that we will have actually two ways of configuring the OSPF. Okay, the first thing we need to do, we need to actually create the instance OSPF. I will utilize 10 for now. Okay, and then remember what we need to configure. We need to configure the router ID. Okay, in this case, I'm just going to use the smallest router ID. And then remember, there is also something called the designated router. And then we have something called the backup designated router. Okay, so the designated router is some kind of a router that gets elected based on the priority and the router ID. So the backup designated router is actually the router that kind of share the same information that the designated router have, so that if the designated router goes down, the backup will be taking the position of the designated router. Okay, the designated router is in charge of central control of all of those OSPF, exchanging information and so on. So the other routers, they don't exchange their information to one another. they send the information directly to the designated router, and then the designated router tells other routers about the link state database of other routers. Okay, now let's come to this configuration network, where we actually need to advertise those networks that are directly connected on those interfaces on the router that we currently running the OSPF on. And then remember, we were gonna be using the wildcard mask of 0.0.0.3, but in this case I'm not gonna use this way of configuring the OSPF. Right, I'm just gonna leave it as it is, and then I will exit as soon as I create the instance. Now all I have to do is I will have to select the interfaces which I want them to be part of the OSPF. In this case, let's start by this interface over here, which is gigabit 0/0. In that case, I can type the command IP OSPF and then specify the process ID, which is 10, and then I can specify the area. This is very important. Now we need to specify the area on an OSPF. Okay, especially in this topology, we're currently using one area, which is the backbone. All right, so we're going to specify the backbone router, area 0, and then press enter. This interface now is part of the OSPF instance chain. Right, so if I go to interface loopback 0 and run the same command, IP OSPF 10 area 0, and then exit, and then go to interface gigabit 0/2 IP OSPF 10 area 0. This simple means now that we have actually successfully configured the OSPF on those interfaces on that router. If I go to the second router, I'm expecting that this router, as soon as I advertise this interface on an OSPF instance that falls under area 0, I must get the neighborship between these two routers. Okay, although these are directly connected, they can be able to ping each other. Okay, but they must also be the neighbors on an OSPF. Okay, so let's do that. How do we do that? We have to go to this interface, which is this one, enable config terminal. Okay, I'm just gonna minimize this. So all I have to do, I have to select the interface, which is gigabit 0/1. For now, before I go to this, actually let me just create the instance, which is OSPF 10. Okay, remember we need to specify the router ID. In this case, let me make it 2. Right, and then I will just exit. Now I have to select the interface that I want them to be part of, the OSPF. If you pay attention now, we will see that there will be adjacency forming between the two. Okay, as you can see, this status tells us that there is a neighbor ID of 1.1.1.1, which is this the router ID of that router running the OSPF. It have created some adjacency, which means they have a relationship now of an OSPF. Okay, so if I run the command do show IP OSPF neighbor, this command will actually show us the neighbor ID, which is that 1.1.1.1, and then the priority that is configured on this router, which is 1 of that neighbor, and then the designated router, and then these are the dead timers. And okay, this is also important. We have something called hello timers, and we have something called dead timers. Okay, so what are hello timers? You can just say it's some kind of a mechanism which is actually useful on an OSPF to actually detect or find out if the links are still connected. Okay, they are still sharing the information. So as soon as one of the interface detach, the dead timers will go down until 0. Okay, so the hello timers, they are 10 seconds by default, but they can be manually configured. And then we have the dead timers, which are 40 seconds by default. They can also be configured, but they must be always 4 times higher than the hello timers, which means if I make, or if I decide that my hello timer would be 20 seconds, that means it must be 4 times the hello timer. Okay, now let's go to the other interface as well, and let's try them to be advertised on this instance. Okay, on area 0 is a backbone, so let's not forget about the loopback interface 0 IP OSPF 10 area 0. Do right. I still have to advertise this network ID of 20.20.20.0, but I'll use the interface to advertise. Okay, so I will just advertise this gigabit 0/0. All right, so what you'll pay attention, if I go to that PC now, I will be able to ping this 40.40.40.2 because at first I couldn't be able to ping it. So if I run the ping now, this time around, I should be able to ping it. Okay, as you can see, I can be able to ping that interface. At least we are moving closer to where we're trying to go, so we can ping towards that interface on the router 2 now. What about this interface? Let's try to ping 20.20.20.2. Ping 20.20.20.2. This is actually trying to show us how important the dynamic routing protocol is. Okay, I'm just going to minimize this, and then we're going to come back to it once we have successfully configured that interface. Now all we're trying to do is we're trying to configure that gigabit 0/0, and we're running the same command IP OSPF 10 area 0. Okay, let's exit. Obviously there won't be any adjacency forming between these two routers from router 2 to router 3 because there is no OSPF currently running on the other router on the other end. Okay, so even if I try to run the command do show OSPF neighbors, I would be able to see only one neighbor to the left hand side, which is router 1. Do show IP OSPF neighbors. I can only see that neighbor, right? I can't see this neighbor until this router also have some sort of the instance running on it. Okay, let me just go to this one. Enable config terminal. So as you can see, this is the router that we have on our right hand side. So if I type in the command router to create this OSPF instance with the process ID 10, I also have to specify this router ID. In this case, I'm just going to use that 3.3.3.3, and then I will exit. This is the highest router ID that we have so far, if we're excluding these loopback interfaces as our router ID, because those are going to be preferred to be used by the router only if the router ID are not configured. If we forget by any chance to run this command on an OSPF instance, then this is going to be used as the router ID. Okay, now let's go to this interface, which is gigabit 0/1. As soon as I run the command IP OSPF 10 area 0, we will see the membership forming, or the adjacency forming between the two. As you can see, this tells me that, well, I have the neighbor, and this neighbor is actually have the router ID of 2.2.2.2.2 on this particular interface, which is gigabit 0/1. Okay. Now, if I go back to that router, I will be able to actually see that I have two neighbors now. This is the same status that is actually displayed on the other router. This router is being told that there is a neighbor adjacent formed between this network ID of the neighbor, which is, this router ID of the neighbor, which is 3.3.3.3.3. This belongs to router 3 again. So if I come here now and run the command do show IP OSPF neighbors, I will be able to see that now I have two neighbors, and actually we have those dead timers. Okay, we have those dead timers, 40 seconds, and these are the addresses that we have. So what's going to happen now? If I go to that PC, I should be able to ping that 20.20.2 that we couldn't be able to ping all along. If I go to that PC on the other end, I should be able to ping. As you can see, this computer slowly, it can be able to try to get somewhere to send the packet to the internet. So we can be able to download any information on the internet. All right. So we need our packet to be actually directed towards that internet. Right. So at least we can be able to get this far to this interface. The problem is, okay, as much as we manage to get to this router, on the same router where when you can try to ping to the internet, we can actually ping. But this, if we try, let me just try to run this ping 8.8.8.8.8. Well, we cannot be able to ping to the internet. Right. I'm just going to run the continuous ping now. This is the moment where we actually have to run this continuous ping and leave it somewhere here so that we would be able to see what's going on as we run some configurations in here. All right. So, okay, let me try to move this a bit. Yeah. We are actually dealing with the router 3 now. Let's advertise this interface also, which is gigabit 0/0. Let's run the OSPF to it as well deliberately, and then let's just exit, and then let's run the interface loopback, which is 0, and also advertise it to this OSPF instance area 0. Okay, there will comes a time where we talk about the not so stubby area, but in this time let's just focus on this one. We will talk about stub areas and not stub area. Okay, let's just come to that one. Okay, we already ran the command. Let's just exit. Okay, now remember, what did I tell you? In this case, when we actually have some sort of dynamic routing protocol, and also we have some sort of static routing protocol running on the same router, there is something that we still have to talk about. It's called redistribution. Okay, so we just need to run some few commands on that router instance. So I need to come here on this router and say router OSPF 10. I want to default to run the command default information originate. Okay, exit. All right. So if I can still try to ping, as you can see, it still won't be able to ping because we need something called the network address translation. Why do we need the network address translation? We are actually, if you take a look in this, on these IP addresses, they are actually all private IP addresses. We have two types. We have private IP addresses, and then we have public IP addresses. Unfortunately, on the internet, the only IP addresses that are used is or are public IP addresses. So in order for our private IP addresses to be able to communicate with an outside world, there must be a conversion that is being done on the router, where on the last router that is facing the internet. Okay, so this is router 3, which is facing the internet, or that we actually willing to convert or translate all of the private IP addresses, all of the packet that come from this side. It must be translated to that public IP address so that it can be able to be routed on the internet, because the internet is also made up of different routing protocol. Usually it's a BGP, which we will still have to talk about. There are different autonomous system numbers that are being utilized on the BGP. So in this case, let's just focus on the network address translation. Okay, let me show this again so that you'll be able to see. As you can see, currently we are actually getting the timeout after we actually run the command default information originate. We are no longer getting that destination host unreachable. Okay, so this tells us that we actually one step close. All we have to do now, we have to configure that network address translation. All right, so imagine now if I actually have a lot of IP addresses coming through this interface, which is gigabit 0/1. If I have 1,000 IP addresses that are private IP addresses, which means I must have 1,000 public IP addresses that must be used for each and every private IP address if I'm using a network address translation. However, there is another way where we can actually use only one private IP addresses but use different ports. Okay, so we can translate so that it's something called PAT, port address translation. So this is what we're going to be utilizing in here, because actually we will be overloading this interface so that when the IP addresses are being translated here, they will come as different ports but with same IP address, okay, which is a public IP. Okay, so let's run that command now. Before we actually configure that, we need to sort of specify which network are actually allowed to access the internet. It's some sort of a policy firewall or something like that, the network policy, where we're actually going to utilize something called the access list. We're still going to touch upon that. We are actually going to use the access list to control which part of the IP addresses or which part of ports or network are actually allowed to access the internet. In this case, I'm just going to go to this router, which is router 3, and then I will have to run the command access list 10 permit, because I'm trying to permit traffic here. I can also deny traffic. So in this case, I can either permit or deny. So I'm trying to actually permit the traffic from any network. Okay, so I'm just gonna run that command. All right, let me try to bring this close again. As you can see now, as soon as I actually ran the command permit, I've allowed the packet to pass through to the internet. Okay, so if I can go here, as you can see, we have now network that is connected to that PC. This PC can now connect to the internet as soon as I have allowed that packet to pass through. All right, so when we're configuring the NAT, we need to actually further say IP NAT source list 10 interface, and then we specify that gigabit 0/0, and then we just overload it. Okay, so we can just overload it, and then we can actually come to this interface, which is interface gigabit 0/1, and then we can say IPNet inside. This is the interface that we're currently talking about, IPNet inside. The PC is already have the internet, and then we can select that gigabit interface gigabit 0/0 IPNet outside. Okay, do right. Okay, so our configuration has been updated. All right, so now we have that PC connected to the internet, so we are expecting to go to that Windows 7. We can utilize that one of the browsers on that Windows or any host device on the other side, and then we can actually try to access the internet and search any web application or any web link, and then we will be able to download the page and see. All right, we're just gonna do that, but let's come in here to show IPNet statistics, or let's just say IPNet translation. All right, so this is the translation that we have currently. All right, so this is the translation that we have. The inside local is using 192.168, so we're expecting to find this IP address on the route. Do show IP route, do show IP route. This is gonna show us the routing table that is gonna be helping us. Remember, this is the default this is the gateway of the last result. All right, and then we're expecting to see that translation IP address. In this case, this is the one. Okay, remember, this is also very important when we're trying to route the packet toward a certain destination. On the routing table, the most preferred or what determines where the packet should be routed, this is the highest prefix match on these entries, network entries. It is the highest prefix match, because this is the directly connected interface. If we can have any device that is actually here on that router, on that falls under this network, we can actually be preferring this this route towards that destination. So it's the highest prefix match, and then longest prefix match, and then it is actually the administrative distance and then the cost. Administrative, the lesser the administrative distance, that is also determine where the packet should be forwarded towards that path. Okay, so I hope this was so informative to you. Let me just go to any browser and then try to see if we can ping on the internet. All right, from that Windows 7 that we have in there. Okay, I'm just gonna do that now. I'm still waiting for this browser to open up. Okay, just gonna minimize this so that you will be able to see. I'm just gonna type in Facebook and see if we can be able to log into Facebook or something like that. Here we go. We can be able to actually see some information on the internet using the dynamic routing protocol. All right, so we have actually successfully configured the dynamic routing protocol with that WAN connection. I hope this video was so informative to you. Let's meet up on an upcoming video as well. Bye.